All right, class, in this lesson we're going to take a look at section 5.2, which is place value systems, and we're going to take a look at the Babylonian numeration system. And so in a place value system, it's also a positional system. It's what we have with our base 10 system. Placement of symbols is in a numeral determines the value of the symbols. And so the Babylonian system, they used only two basic marks. They've got this sharp triangle, which represented 1, and then this interesting other character, which represents 10. So 23, what you would do is you take 2 of these and put it next to 3 of these shapes, and you've got 20 and then 3. And so to represent larger quantities, Babylonians used several groups of these symbols, separated by spaces, and multiplied them by values of these groups by increasing powers of 60. So they had a base 60 system, which is odd. Instead of base 10, they use base 60, but it shouldn't be too odd to us because that's exactly the number system that we use for counting time. So we've got to convert a number like this one where we've got 2 marks, a space, and then we've got 3 10s and a 1 space, two of the 10s and another 3 into our Hindu-Arabic notation. So what we're looking for is that these are units. In other words, these are just like regular numbers. If this adds up to 59, we're good. And then over here we've got a space for our next power. But anyway, so we've got 23, just like we had earlier. And then here we've got to multiply this quantity by 60, because every time we separate it by space, this is an increasing amount. And so we look at it, and there's 31, but it's 31 groups of 60 is what that represents. So it's 31 times 60. So again, this is our units, and over here, and this is telling you how many groups of 60 you have. And then, so that's 31 times 60. And then over here on the left, you've got 2 of these marks, and that's 2 groups of 60 groups of 60. So this is 2 groups of 60 groups of 60, which is, we have to multiply it by 60 squared. So this is 2 groups of 60 squared, 60 groups of 60. Okay. So when you're multiplying this out, the first group you just get to count as units. The next section you've got to multiply however many are here by 60. And the next time you have to multiply how many are here by 60 squared. And then the next group, if there was one, you'd have to multiply by 60 to the third, and it would keep growing. And so you actually have to do the work here of multiplying 60 squared, finding out that's 3,600 times 2. Then take your 60 and your 31 and multiply them, and then add the 23. And when you put it all together on your calculator, you get 9,083 is what this number right here represents as far as the Babylonians converting it to our number system. Okay, so we've got Babylonian subtraction. Babylonian subtraction uses this interesting symbol here where they take a 1 and then it's like they flip their other symbol and squished it and put it on top. And so this, whenever you see it, means subtraction. So in other words, we're subtracting these 2, which are 20, minus 3. So 20 minus 3 should be 17. That's exactly what we would be doing here. So you represent this as 20, 3, or subtracting 3, and you get 17. So the Hindu-Arabic numerals are converting it to Babylonian numerals. We have to divide by powers of 60, similar to the way that we convert seconds to hours and minutes. For example, if we had 7,717 seconds to hours and minutes, we would divide by 3,600, and we would get it into the number of whole hours. So let's take a look at actually doing that. If we had 7,717 seconds, if I wanted to figure out how many hours and minutes I have to divide it by 3,600, and what that would tell me is that there's 2 hours. The reason why I'm doing that is because hours are 60 times 60. So if I'm taking my seconds to hours, there are 60 minutes in every hour, and then there's 60 seconds in each minute, so we have to multiply 60 times 60. So 1 hour is equal to 60 times 60, and so that's 3,600 is what we're dividing. So this is seconds divided by, this is how many seconds are in an hour, so that goes in twice, which means that this represents 2 hours, and then there's a leftover of 517 seconds. So if I'm trying to convert to hours, minutes, seconds, we have to divide this 517 by 60 again, so we could figure out we've got 2 hours and how many minutes. And so we're going to do that division right now. And it looks like this, where you take the 517 and we divide it by 60. And because this is still seconds, if I divide it by groups of 60, it tells me how many groups of 60 I have, and each group of 60 seconds gives you a minute. And so it goes in 8 times, so you have 8 minutes, and the leftover is 37 seconds. So altogether, you've got your 7,717 overall seconds, gives you 2 hours, 8 minutes, and 37 seconds. The way that we just rolled this math out is exactly how we would take a regular number, like what we have, and rewrite it as Babylonian numbers. And so basically, if I was to write this as a Babylonian number, they would take my 2 hours and they would put your just 2 marks of the actual shape that they have. Sorry, my drawing is not going to be very good. 2 hours, 8 minutes, and so then they would put 8 marks, and then our 37 seconds, they would actually do their 3 of these, and then 7 other marks. So this would be how you would write this number in, if I was to do it into Babylonian math. Okay, so that's exactly what we're going to take a look at. So we've got 12,221. To write it as a Babylonian numeral, you start off by dividing it by 3,600. Apparently I thought I was going to show the division. So we've got our final answer down here. This is where we're going to be. But you need to take this number and take our 12,221 and divide it by 3,600. And that'll tell you how many groups of 60 squared you have. So this will tell you groups of 60 squared. And as we find out down here, there's going to be 3. So basically, I would just do this on my calculator. You can actually do the longhand division if you want, but we need to figure out what the remainder is why it would be a good idea to actually do it with a long division. Our process of long division is probably our best method here to get the actual remainder itself. And so if we realize that it goes in 3 times, you take your 3 and times it by your 3,600, and that should give you 10,800. And then you subtract by your 12,221, and you should be left over with 1,421. And then you have this as your remainder because 3,600 doesn't quite go in. And so what we do is we say this is our remainder, so we've got 3 groups of our 60 squared. And then what we need to do is take this 1,421 and divide it by our next group down. So we go, the groups go by, it's 60 squared, and then it's 60, and then it's our ones. So the next group we need to divide by is 60. And so we take 1,421 divided by 60, and it's going to go in 23 times, as we see down below. By below, I mean down here. And so you take your 23 and times it by 60, and that tells you we've got 1,380. If you subtract, you've got 1,421. You've got your 41 left over, and so that is our 41 remainder down here. So the process is just like we're dividing by hours, minutes, and then the leftover is seconds, is exactly how the Babylonian numbers get converted from Arabic notation. So the way that we would actually write this number is you've got 3 of their marks, which means 3 groups of 60 squared, and then you've got 23, so 2 and then 3 units of 60, so 23 units of 60, and then 41 left over. So this is how they would have written the number 12,221. So now we're going to take a look at the Mayans. And what I'm going to do is I'm going to make another recording. So click on the next link to find to watch the rest of this.